When you click on the Gowdy Output tab in the Manager module, the Gowdy Output dialog is displayed in a separate window. Gowdy Output, conceived in spreadsheet form by Mark Gowdy of California's Central Valley Regional Water Quality Control Board, is designed to show the inputs and outputs of flow or loading occurring along a river reach to determine the relative contribution of sources at the downstream end of that reach. The river reach is defined in the Setup tab of the Manager module. The output includes three components: the longitudinal concentration plot, the cumulative loading plot, and the source allocation bar chart. When the dialog is initially displayed, flow is shown by default. The date in the dialog is the beginning simulation date. The date box has associated up and down arrows. You can change the date by clicking on these arrows and see how the contributions of flow from each of the individual sources changes through time. You can review the Gowdy output for other WARMF parameters by selecting a different parameter from the Parameters drop-down box. Gowdy output is available for flow and all chemical constituents, but not temperature or other hydrologic parameters such as water depth or velocity. The upper right portion of the Gowdy output dialog contains a longitudinal output plot, which shows how total dissolved solids concentration changes according to location along the selected river reach, as defined in the Setup tab. In this graph, total dissolved solids concentration is illustrated using a black line, while flow is illustrated using a blue line. The longitudinal output displays simulation results from all the river segments in the selected reach. The x-axis has river miles calculated from the length of each river segment. The primary y-axis shows the concentration of total dissolved solids in milligrams per liter, while the secondary y-axis displays stream discharge in cubic feet per second. In the lower right portion of the window is a cumulative loading plot showing cumulative total dissolved solids inputs and diversions. Total dissolved solids inputs are illustrated by the green line and diversions are illustrated by the red line. The net flow present in each river reach is illustrated by the black line. The individual sources and sinks of total dissolved solids that are used to calculate the results illustrated in the cumulative loading graph are presented in the bar chart on the left. The sources and diversions are added in at the locations where they occur along the river reach. You can turn in-stream processes on and off by clicking on the radio buttons located above the source allocations bar chart. In-stream processes include settling, decay, chemical transformations, and diversions. Therefore, the difference between accounting for in-stream processes and ignoring them is the difference between the load to the river and the load that reaches the downstream end of the river reach. Certain chemical parameters are more reactive than others, so the difference between results generated using these two approaches will vary based on the chemical parameter that is selected. When in-stream processes are accounted for, the inputs minus the diversions should be approximately equal to the net load in the river, although there is a small amount of error inherent in the calculations. When in-stream processes are ignored, the inputs minus the diversions could be very different from the net load. The three export buttons at the bottom of the dialog are used to put the values in each of the three charts into comma-delimited text files. You can export the results of the Gowdy output using these buttons if you are interested in conducting further analysis on the data, constructing other types of charts for a presentation or a report, or comparing data from multiple model runs.